what is the change in entropy if we isothermally increase the pressure from 9 Pascal to 20 Pascal? In this example, assume that we have 4.5 mole of ideal gas. Please pause the video to do this example, please. So the equation for the change in entropy is given by the heat of the reversible process divided by temperature. Because we have an isothermal case, this means the change in internal energy is 0. The change in internal energy is the sum of the heat and the work, and therefore we can write that the heat of the reversible process is equal to the negative work, which is equal to the number of moles times the universal gas constant times T, the temperature or the absolute temperature, times the logarithm of the final volume over the initial volume. So we can write the change in entropy is the number of moles times the universal gas constant times the logarithm of the final volume over the initial volume. But we want to know what is the pressure. So we have the equation again, but we know Boyle's law. And Boyle's law tells us that the initial pressure times the initial volume is equal to the final pressure times the final volume. So if you want to now solve for final volume over initial volume, which is equal to initial pressure over final pressure. So we can include this now in the equation, and we have 4.5 moles. The universal gas constant is 8.3145 joules per Kelvin per mole. And then we have the logarithm of 9 Pascal over 20 Pascal. And we see we have a negative change in entropy, which is minus 29.9 joules per Kelvin. So even though the change is pretty small, it's important to note if we increase the pressure, we reduce the entropy.